Hello students, this is Lalit Yadav and I am going to deliver the lecture on the cam and follower. So what is the cam? Cam is the rotating element. This is the cam and this is the rotating element, and it provides the reciprocating motion to the follower. Here it is the center of the cam. This is called the camshaft, and the end of the follower is the flat face. Then it is called the flat face follower. And this is the slide in which the follower is moved up and down or the reciprocating. So this cam and the follower arrangement is used in the IC engine to operate the inlet and the outlet valve. This is the cam position and this is the follower, and it is connected with the inlet and the outlet valve of the IC engine. So it can operate the IC engine valves by this cam mechanism. As already see in this diagram, so this is the cam and this is the follower, and it operates the inlet and outlet. Now this is the classification of the cam mechanism. This is on the based on mode of input and the output motion. First, the cam rotating and translating follower. Second is the rotating cam again and the oscillating follower. And the third is translating cam and the translating follower. So this is the classification of the followers according to the shape of the follower. First is knife edge follower, ruler follower, flat face follower, spherical follower. So in this diagram, here you can see the end shape of the follower is with knife edge, then it is called the knife edge follower. So when the cam is rotate, this knife edge follower is moved up and down, and also called the reciprocating motion of the knife edge follower. Here the end of the follower with the roller, okay, and this is the contact surface of the cam. So when the cam is rotate, this is rolled on the surface of the cam and also reciprocate on this slide. In the third diagram, here you can see this is the flat face follower, and this reciprocate in this slide, and the shape of the follower is the flat, then it is called the flat face follower. The fourth type of the follower is the spherical shape. Because the end shape of the follower is the spherical shape, then it is called the spherical face follower. And this is the reciprocating type. In the fifth type, this is the spherical follower, but it is the oscillating motion take place about this point. And this is again the flat face follower, but here it is show the offset follower, because the axis in all diagram, here you can see the axis of the follower is coincide with the axis of the cam, and in this diagram here you can see the axis of the follower is not coincide with the axis of the cam. There is some distance between the axis of the cam to the axis of the follower, then it is called the offset follower. This is the working of the knife edge follower. You can see in this diagram. This is the working of the ruler follower. This is the flat face follower. This is spherical face follower. Now the second type is according to the path of motion of the follower, that is called the radial follower or the offset follower. Radial follower means when the axis of the follower is coincide with the axis of the cam. In every diagram here you can see the axis of the follower is coincide with the axis of the cam, then it is called the radial follower. In the offset follower, here you can see the axis of the follower is not coincide with the axis of the cam. There is some distance, then it is called the offset follower. Now the classification of the cam. First is the radial or the disc cam. Second is the cylindrical cam, and the third type is the end cam. The radial or the disc cam, here you can see the shape is the clear shape, but it is called the disc type or the radial type of the cam. So in the radial cam, the follower is reciprocate or the oscillate in the direction perpendicular to the axis, cam axis. This is the cylindrical cam. So here you can see the shape of the cam is the cylinder. So in the cylindrical cam, the follower is the reciprocate or the oscillate in the direction parallel to the axis of the cam. This is the end cam. This is called the end cam, and this part is the reciprocate on this surface. So this is also similar to the cylindrical cam, but the follower makes the contact at the periphery of the cam. So this mechanism is used in the sewing machine. Now the cam nomenclature. First, the cam profile. So here you can see this is the cam profile, which is the outer surface of the disc cam. This is the cam profile. This line, this curve shows the cam profile. Second is the base circle. So this is the uh, base circle. This is the base circle, which is the circle with the shortest radius from the cam center to any path of the cam profile. Now the trace point. So here you can see the axis of the follower is the center of this roller. Then it is trace the path by this. This is passes from this uh, trace point. So this is also called the pitch curve. So it is passes from the pitch curve. So the center of the roller is shows as a trace point. Pitch curve. So this is the important curve, and here you can see this is the pitch curve. The path is generated by the trace point at the follower. This is the rotate about the stationary cam. Now the prime circle. So this is the prime circle. This is also called the prime circle, and this is also called the base circle. The path generated by the trace point at the follower is rotated about the stationary cam. Prime circle is the smallest circle from the cam centered through the piston. Now the pressure angle, the angle between the direction of the follower movement. This is the direction of the follower movement and the normal to the pitch curve. This line is normal to the pitch curve, so this angle is shows as a pressure angle. Pitch point. So this is the pitch point. Here you can see where we draw the pressure angle. The pitch point is corresponding to the point of the maximum pressure angle occurs. Then it is called the pitch point. Pitch circle. We already shows the pitch circle part, and stroke is the greatest distance or the angle through which the follower moves rotate. If the follower moves from here to here, then it is called the stroke. Now the motion of the follower, as the cam rotates, the follower moves up and down. So upward movement of the follower is called the rise or the outstroke, and the downward movement of the follower is called the return stroke or the fall. When the follower is not moving up and down, when even when the cam rotates, it is called the dwell. So these are the types of the follower motions: uniform motion, simple harmonic motion, uniform acceleration and retardation, cyclodal motion. So first we discuss about the uniform motion or the constant velocity motion. So here it is the on the x-axis. Here we take the cam angle. On the y-axis, here we take the displacement of the follower, and this is also called the stroke. So the distance from here to here is called the stroke, and distance from here to here is called the out stroke when the angle of the cam rotation during the out stroke. Distance from here to here, so this is called the cam rotation during the out stroke. This is the dwell period from here to here. and the distance from here to here is called the cam rotation during the downstroke. So this is the displacement diagram for the uniform velocity when the follower is moved with uniform velocity. This is the second diagram that is called the simple harmonic motion. So when the follower is moved with the simple harmonic motion, so distance from again on the y-axis we take the stroke, on the x-axis we take the rotation of the cam. So here you can see from here to here, this is the from 0 to 180 degree. This is the out stroke of the cam, out stroke rotation of the cam, and the dwell period is 0 here, and this is the fall or the downward movement of the follower, and when the cam rotates from 180 to 360 degree. So this is the one complete revolution of the cam. Third type is the uniform acceleration and the retardation. Since the acceleration and retardations are the uniform, throughout, therefore the velocity varies the direction with the time. So this curve shows with the help of the uniform acceleration when the speed is increased, and this is the retardation when it is moved downward, the speed will be decreased. And here it is the velocity diagram is also shown. So this point from here to here is called the maximum velocity, and this is the distance from here to here is called the maximum retardation velocity. And similarly, this is the maximum acceleration at outward stroke, and this is the maximum acceleration of the retardation stroke. Fourth type is the cyclodal motion. In this motion, here you can see the curve is generated like that. So this is the curve of the out stroke, and similarly, the same curve is obtained for the return stroke. And here you can see the maximum velocity in the case of cyclodal motion and the maximum acceleration in case of the cyclodal motion are at the out stroke, and this is the return stroke. Now the first column is on the uniform velocity diagram, displacement diagram is with the uniform velocity, and here the cam is giving the following motion for the knife edge follower. The knife edge follower is used. So in the numerical here you can see the out stroke value is given in the terms of cam rotation, that is the 60 degree. The out stroke during the 60 degree of the cam rotation, dwell for the next 30 degree of the cam rotation, return stroke during the next 60 degree of the cam rotation, and dwell for the remaining 210 degree of the cam rotation. And the stroke of the follower is the 40 millimeter. This is the value from here to here. This is represent here 40 millimeter is the value of the stroke of the follower, and the minimum radius of the cam is 50 millimeter, and the follower moves with the uniform velocity during the both out stroke and the return stroke. Okay, so in both the cases, here we take the uniform velocity condition. So this is the important condition. We already discussed what is the uniform velocity. Draw the profile of the cam for the axis of the follower passes through the axis of the camshaft. So first condition we take. Now first of all we draw this line according to the cam rotation. So here we consider the one degree equal to one centimeter. So here, sorry, 1 millimeter. So distance from here to here is 1 centimeter, which represents the 10 degree of the cam rotation. Similarly, distance from here to here is 1 centimeter. So this is again the 10 degree shows. So the total cam rotation is given is 60 degree. So the distance from here to here is 6 centimeter. The distance from here to here is 3 centimeter for the 30 degree of the cam rotation, and the distance from here to here is again the 60 degree of the cam rotation. So distance from here to here is 6 degree, and the remaining you can take any distance. So when we join the from point here to here, so a uniform velocity will be shown. Okay, so the red line shows the uniform velocity during the out stroke. This is the dwell period, and the uniform velocity during the return stroke. So this diagram is called the displacement diagram. Now we can draw the cam profile. So we use the cam radius value. So we take the 50 millimeter of the cam radius value. So first of all, we draw this circle. So this is the circle of the 50 millimeter radius. So first of all, we draw this circle and mark the point O, that is the center of the circle, and now draw the vertical line. So on this vertical line here we show the knife edge follower, and this is the 40 millimeter. So distance from here to here is called the stroke. So here we showing the stroke of the follower. Okay, and the shape of the follower is the knife edge follower. Now from this point, from this vertical line, we measure the angle which is given for the out stroke, dwell and the return stroke. So we put the protector here and measure the angle 60 degree from here to here. This is the angle of outer stroke of the cam. Okay. Now again we put the protector here and measure the angle 30 degree, and then measure the angle 60 degree, which is the return stroke of the cam rotation. Okay. Now after that, we divide the divisions in the displacement diagram. Okay, this is the sixth part. So similarly, here we are dividing this angle 60 degree in the six equal parts in the outer stroke. There is a no need to divide the dwell period, and again the sixth division in the return stroke. Okay. Now we draw the line. This is the extensions line from the O point. So we draw the line. So we already given the marking from 1 to 6 and 0 dash to 6 dash. So we draw the line from the O point and it is extended of any length. Okay. So we extend the return stroke extension line also. Now we take the distance from 0 to A, that is the no distance. Now we take the distance 1 to B and mark on this curve. So distance from here to here is 1 to B distance, which is taken from the displacement diagram. And the OA is the same point. And now we take the distance from the displacement diagram is 2 to C distance. 2 to C distance. So you can take this distance with the help of the compass and mark the compass on these line, extension line. So this is the 2C distance. Similarly, we take the distance from 3 to D from the displacement diagram and cut the arc on this extension line and repeat the process for all the points. Now after that, join all the points from here, A to B, B to C, C to D, E, F, E, then H, J, K, L, M, N. So this is the dark part you can draw with the help of the dark line. So this is called the cam profile. So this is our aim, to draw the cam profile in this format. Thank you very much.